Hi guys. So what we're going to do today is we're going to look at quadratic inequalities. So we're going to start by looking at how to graph these, and then what we're going to do is we're going to solve them algebraically. So in order to graph these, it's really pretty similar to what you did with graphing linear inequalities. The same rules about solid lines and dashed lines are still going to apply. If it's or equal to, it's going to have that solid line. If it's not or equal to, you're going to have that dashed line. So on this first one, we're really just going to refresh how to graph this. Okay, this one's in vertex form, so it's easy to see the vertex is at 2, 5. This graph has been reflected and compressed, so we're going to change it from the parent function pattern. That's your typical parent function pattern. But again, we're compressing it by 1/2 and reflecting it. Whoops. So we're going to go right 1 down 1/2, right 2 down 2, right 3 down 4.5, and right 4 down 8. And then we have those same points on the other side. So since this graph here is not, it's y is less than, not or equal to, this is going to be one of those dashed lines. So now with the shading, okay, so all of our shading when it comes to these is either going to be everything outside this parabola or everything inside the parabola. To figure out which one, what we do is we look at the vertex. And it's either going to be above or below the vertex. So very similar to what we did with lines. Okay, if we had y is less than 2x, we shaded below 2x. Same thing here. If y is less than, we're going to shade below. And what we're going to do is shade below the vertex. If below the vertex is inside the parabola, we're going to shade inside the parabola. If below the vertex is outside the parabola, we'll shade everything outside the parabola. So not just what's below, we're shading either inside or outside, but we're using that above below to help us figure out which one. All right, on this next one, we can either use negative b over 2a to get the axis of symmetry and the vertex, or we can rewrite it in vertex form. I'm going to rewrite it in vertex form by completing the square for practice. So I need to factor out that 2. So the number that's going to go in that blank, 2 divided by 2 squared is 1. But I didn't really add 1 to this equation. Remember, I added 2 times 1. So to keep it balanced, I need to subtract that same amount. So I haven't changed this equation. I've added 2 and I've subtracted 2. Well, now I can rewrite this. This becomes x minus 1 squared minus 1. So now I can see my vertex is at 1, negative 1. I can see I have a vertical stretch by a factor of 2. So your typical pattern, I would go right 1 and up 1, but multiply that by 2. So right 1 and up 2, and right 2 and up 8. Whoops. This one is a solid line because it's or equal to. And since we're dealing with less than, we're going to shade below the vertex. This time below the vertex is outside the parabola. So again, we're not just shading what's below the vertex. Because below the vertex is outside, we're shading everything outside the parabola. And that's my graph. All right, so what we'll do now is we're going to combine this with what we did last class, and we're going to look at a system of inequalities. So again, some graphing practice. These are all in vertex form, so hopefully pretty easy. This first one has a vertex of 1, negative 3, compressed by 1/2, so right 1 up 1/2, right 2 up 2, and then right 3 up 4.5. And right 4 up 8 if you want to get another point. This one is going to be a dotted line because it's or equal to, no, sorry, it's not or equal to. All right, second graph. Vertex is 2, 4. This one has been reflected and stretched by 2. So we're going to go right 1 down 2, right 2 down 8. All right, so now let's look at our shading. So on this first one, it was y is greater, so we were shading above the vertex. Above the blue vertex is inside that parabola. The purple one, we're shading below the vertex. Below the vertex is also inside the parabola. So the system of inequalities is inside both parabolas, so that overlap would be here. So it says to give 2 possible solutions, so any point in that shaded region. Okay, 2, 0 is a possible solution. 2, 1 is a solution. 2.1 is also a solution. So anything that falls within that shaded region would work. All right, let's look at the next one. So vertex there would be negative 3, 2. This one, it has been compressed and reflected, so that normal parent function pattern, we're compressing it and reflecting it. So I would go right 1 down a fourth, right 2 down 1, right 4 down 4. And that's, again, those are always in relation to the vertex. Keep that in mind. All right, that one's going to be a solid line because it's or equal to. Its y is greater, so we're going to shade above the vertex, which is outside that parabola. All right, let's look at the next one. Negative 1, negative 2 is the vertex. No stretches or compressions or reflections from the parent function. So normal parent function pattern. Right 1 up 1, right 2 up 4, right 3 up 9. This one is a dotted line. All right, so we are shading in this case above the blue vertex. Above the blue vertex is inside that parabola. So the overlap here is going to be inside the blue and outside the purple, which is all of this region right in here. So again, two possible solutions. There's lots of them. Let's just say 0, 3, and let's say negative 1. Negative 1, 100 is still going to be within that range. So lots of different possibilities here. All right, so again, we're going to look at these algebraically now. So similar to the last video, you're going to see the background change to purple because it's the same examples that we used on the GT video, and we're trying to save some recording time. So again, from this point on, we're just going to look at solving these algebraically. So in order to solve these algebraically, we're going to use something called a sign chart. Okay, and I mean sign like positive, negative sign, not like the sign that you did last year in geometry. All right, so by the sign chart, what I mean is the first thing we're going to do is find our zeros. So for all of these, it's really extra practice in solving quadratics. So the first thing we're going to do, if it's not already, set it equal to 0, and then find your zeros. So in this case, this first one is already equal to 0, and we can factor. Okay, what multiplies to negative 4 and adds to negative 3 would be negative 4 and 1. Once we know our zeros, we're going to mark those on a number line. And then what we're going to do is we're going to pick some test points. Now, the process that we're using here, we are going to use in later units. So even though we'll see some patterns here, you guys will notice, it's still important to understand this process because we're going to use it again in some future units. So what we have here basically is we're going to figure out where this graph is positive and negative. These 2 points that are marked are the 2 zeros. Well, what we know is every x value to the left of negative 1 is going to be either positive or negative. It can't change between positive and negative because it would have to cross the x-axis. And the only 0 that I have right now over here is negative 1. So if something over here is positive, everything over here is positive. If something over here is negative, everything over there is negative. So what we do is we pick a test point that falls in this region. It can be any number that you want, okay? It could be negative 2, it could be negative 1,000. They're going to have the same positive or negative sign. So I'll just go ahead and pick negative 2. That's my test point. If I take negative 2 and I plug it in for x, I don't need to know exactly what that value is. All I need to know is this going to give me a positive or a negative number? Because whichever one it gives me, that's going to be true for everything that's on this side of my inequality. So if I plug in negative 2 minus 4 is a negative number. Negative 2 plus 1 is also a negative number. Those two things are being multiplied together, and a negative times a negative is always going to give me a positive. So what that means is that everything to the left of negative 1 is a positive number. And again, I could pick any number to the left of negative 1. Okay, I could pick negative 7. Negative 7 minus 4 is a negative. Negative 7 plus 1 is a negative, and a negative times a negative is a positive. Okay, you're going to keep getting that same answer. So now we go to our next region, somewhere in between negative 1 and 4. Okay, so I'm going to pick any test point that falls in that region. Let's pick 0. Okay, if I plug in 0 for x, 0 minus 4 is a negative number. 0 plus 1 is a positive number. And a negative times a positive is always going to work out to be a negative. So that means everything in that in-between region is going to be negative. There's not going to be any positives because if there's one negative down here, the only way to go to the positives is to cross the x-axis. And I don't cross the x-axis again until I get to 4. So now let's look at this last test region. All right, 4. So I can pick anything to the right of 4. Okay, I'm going to pick 100, because again, it could be anything. If I plug in 100 minus 4 is a positive number. 100 plus 1 is a positive number. And a positive times a positive is positive. So now my sign chart is filled in. This tells me where this graph is positive and negative. What I'm going to do is I'm going to use this chart to answer my question. The original question wanted to know, when is this inequality less than or equal to 0? Less than or equal to 0 means it's negative. So we're trying to figure out, where is this graph negative? Well, that graph is negative in this region right here. So we're going to write our final answer in interval notation. So from -1 to 4. Because it's or equal to, we're going to use brackets. All right, let's look at our next one. Again, first step, set it equal to 0 and find the zeros. So I'm going to rewrite this. And then this question can factor. Okay, there's something that multiplies to -20 and adds to -10. I'm going to go ahead and do this just with guess and check. It's a little bit faster because I've got some prime numbers. So 2x and x. And then these numbers here, we know they have to multiply to a -10. Okay, so I just need to check those middles. I need those middles to add to a -1. So I'm going to use 5 and 2. I'll make this one 5 and this one 2, because that's going to give me 5x and 4x. One of them has to be positive and one of them has to be negative in order to get this negative. Because I want it to be a -1 in the middle, then I'm going to make that one negative and that one positive. So that gives me 2x squared minus 10, and then a minus 5x plus 4x in the middle. Now again, you don't have to go through this way. If you want to go through the AC and split the middle, you are welcome to do that. Just showing that process as well in case you guys are getting a little faster at some of these. All right, so now we know our zeros, -2 and 5/2. So now let's pick some test points to plug in. So let's pick something in this region here to the left of -2. All right, so -3. 2 times -3 minus 5 is a negative number. -3 plus 2 is a negative number, and a negative times a negative is, in fact, a positive. So this region is positive. Okay, something in this region, like 0. 2 times 0 minus 5 is a negative. 0 plus 2 is a positive. A negative times a positive is negative. All right, let's go to the next one. Something to the right of 5/2. Again, let's do 100. Okay, 2 times 100 minus 5 is a positive. 100 plus 2 is a positive. Positive times a positive is overall going to be positive. So this region is positive. Now let's answer the original question. It wants to know when this quadratic is greater than 0. So when that quadratic is positive. The positive regions here, from -infinity to -2, we need to use a parenthesis because it doesn't actually touch that point. And then it continues from 5/2 to infinity. And that's our region. Now you'll probably notice some patterns here, okay? This one went positive, negative, positive. This one went positive, negative, positive. Kind of an easier way to help you guys realize this. It's good to know how to plug in those test points because, again, we're going to use that later on this year. But what you might notice, this is the same shape as the graph, okay? This graph, if you were to sketch it, this is a 0 and this is a 0. This graph opens up. It's a positive a value. Since it opens up, your graph is going to look something like this. Same thing over here. So this graph is positive until that x value, positive after that x value. So knowing the shape of that graph can help you figure out these sign charts a little easier. All right, let's look at another one. Now this is one you got to be careful on, okay? Because what you might want to try and do is you might just say, well, let's square root, hey, x is greater than or equal to 5. That's not my answer. The reason that's not my answer is because the square root of x squared is not actually x. It may seem like it's x, but it technically isn't. Actually, the square root of x squared is the absolute value of x. Because if you think about it, let's say this was just x squared equals 25. The answer for x is not just 5. The answer to x is also -5. So to make this easier than having to deal with those absolute values, what we're going to do is we're just going to do the same process. Set it equal to 0. Now this is the difference of squares, which is easy to factor. I know where my zeros are. this graph opens up. It's a positive a value, which means this shape of this graph, it's going to be positive, negative, and positive. Again, I can pick those test points if I want to be sure, but I know what this graph's going to look like. If you want to pick a test point, plug in 0 just to see. 0 minus 5 is negative, 0 plus 5 is positive. Negative times a positive is in fact a negative. Okay, you can do that for all those points to double check if you want. Look at your original question. It wants to know when it's greater than or equal to 0. So we're listing the positive intervals. So negative infinity to negative 5 and 5 to infinity. Brackets because it's or equal to. All right, going on to the next one. X squared plus 4x minus 3. Now in this case, this is something that does not factor. So what I'm going to need to do, now if it was plus 3, then it would factor. But this one's not going to factor. So I'm going to use the quadratic formula or completing the square. It's up to you. We'll do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 4 plus or minus, that's going to be 16 plus 12, which is 28. Remember, at this point, we cannot simplify this. All right, so we need to simplify the square root. That becomes 2 root 7. And now, since both of these are able to be simplified, we can. That becomes negative 2 plus or minus root 7. So I have negative 2 plus root 7. Oops, sorry. Minus root 7 is going to be smaller. I should put that one first. There we go. Negative 2 minus root 7 and negative 2 plus root 7. And that looks like a 2. All right, so if I would again pick those test points and plug them in, you can do that. But since it's kind of hard to tell where negative 2 minus root 7 and negative 2 plus root 7 are, this is why it's helpful to understand what the graph looks like. Okay, again, this graph opens up. It's a positive a value. The graph would look something like this. So it's positive, negative, and positive. Original question wants to know when it's negative. That negative region does not have parentheses. Sorry, does have parentheses because it's not equal to. And that's the negative region. All right, we're just going to do a couple more, look at a couple specific cases. All right, let's try this next one. Again, first step, get a set it equal to 0. So negative x squared plus 5x plus 14 is less than 0. So in order to factor this, there's a couple different things you can do. To me, I think it's easier to just go ahead and factor out that negative from all 3 terms. I think that makes it easier to factor. You don't have to do it that way, but to me it's a lot easier because now I can see, hey, this is going to be x minus 7 and x plus 2. All right, so my zeros are negative 2 and 7. But this time, because of that negative out there, what that means is if I were to sketch this graph, that a value is negative. This graph is going to open down, which means this graph is going to be negative, positive, negative. Original question wants to know when it's negative. So that negative region, negative infinity to negative 2, and then 7 to infinity. Another way you could work this out from the very beginning, you could just rewrite it as and move everything over here to the right side. So you could just make this 0 is greater than. Sorry, we're moving everything. 0 is less than x squared minus 5x minus 14. So you could work it out this way. Okay, and then your group sign chart would look different, but your answer would be, and again, this time now looking for the positive region, which would be positive, negative, positive. You'd still get the same answer in the end. So that's just a different way that you could work that out if you wanted to. But I wanted to show you guys one with a negative a value so you could see that flip sign. All right, looking at the next one. Again, this one does not factor, so let's either complete the square or do quadratic formula. I'll go ahead and do completing the square this time. So x squared plus 2x plus blank. Move that 6 over. I'm going to add a 1 to both sides. So x plus 1 squared is equal to negative 5. Well, you guys can tell at this point, when you square root this, I'm going to get the square root of negative 5, which means that there are no real solutions. Now, the nice thing about this, is that you don't need to find imaginary solutions, okay? We're trying to answer, when is this graph above the x-axis? Okay, that's what it's saying. When is this graph greater than 0? When is that graph positive? By getting negative answers or square root of negatives, that's telling us there's no real solutions. That's telling us this graph has no x-intercepts. So let's think about what this graph looks like. If there's no x-intercepts, that means that this graph opens up. Okay, it opens up, it doesn't cross the x-axis. So now we can answer our question. We want to know when this graph is positive. Well, this graph is always positive. There's no x-intercepts and it opens up. It doesn't matter where it is. Okay, it can be anywhere over there. But wherever it is, it's always going to be positive. So this answer is all real numbers. All right, last two. Again, just kind of looking at some special cases here. So on this next one, again, first thing, set it equal to 0. All right, so then at this point, you know that that factors into x minus 4 squared. Sorry, I did that kind of quick. That is a perfect square trinomial, which means there's only one 0. Your only 0 is 4. Okay, that's also where your vertex would be. So again, if you want to pick some test points, you can. Let's say I pick some test point in this region, like a -7. -7 minus 4 is a negative number, but a negative number squared is a positive. Pick some number in this region. Okay, 10. 10 minus 4 squared. That's also going to be positive. But everywhere on this graph is not positive. So this answer is actually not going to be all real numbers, because when x equals 4, it's 0. And 0 is not a positive number. It wants to know when this graph is greater than 0. So this graph is greater than 0 from -infinity to 4, and then again from 4 to infinity. Now, if this was greater than or equal to, then it would be all real numbers. All right, last one. So again, here, this one is not going to factor, so we can do completing the square or quadratic formula. To me, this is an easier quadratic formula question because you've got an odd number, an a value, and those are just easier with quadratic formula. So -3 plus or minus square root b squared minus 4ac all over 2a. And you'll notice over here, this is going to be 9 minus, let's see, that's 8 times 7 minus 56. That's going to be a negative number. Okay, we don't need to know what the value is. Again, we're not finding imaginary solutions. We're just trying to say, when is this graph greater than or equal to 0? What we know right now, okay, is that this graph has no x-intercepts. There are no real solutions. We also know that the a value is negative. That means that this graph's going to open down. Well, if it's going to open down and not cross the x-axis, it has to be somewhere down here. That means that graph is always going to be negative. The entire graph is going to be negative for every x value. Well, if I want to know when this graph is positive, that means that there are no real solutions. All right, so that is it for quadratic inequalities. As you guys can see, this is really a lot of review on solving quadratics, and then just that extra step of plotting those zeros and figuring out where your graph is positive and negative.